In today's note, we are going to be looking at the length of a line segment, or distance between 2 points, which is basically the same thing. Because if we're looking at the length of a line segment, we're going to be using the two endpoints to help us with that. So it's basically the same thing. So to find the distance between 2 points, we can use Pythagorean Theorem. And I already have it written out over here at the side, and it may look a little bit confusing, but let's look at our example here. So here we have our line segment, let's call that C, and we have our two endpoints. We have x2 and y2, x1 and y1. So those are our 2 points, and we need to figure out what is the length of this line. And the reason we say we can use Pythagorean theorem is because if I were to make a triangle out of this straight line, it may look something like this. If I were to make a triangle like this, that would be a right angle triangle, and the side C would be my hypotenuse. So that means I have B could be over here, and then A would be over here. Right, so we know from Pythagorean theorem in our first step over here that C squared is equal to A squared plus B squared, or the hypotenuse is equal to this side squared plus this side squared. Now, how can I figure out the length of B and the length of A? Because once I can figure out that, what this whole length is, then I can plug that into my formula. So if I'm looking at this entire length, I know I start up at y2 and I drop down to y1. So this overall length is going to be y2 minus y1. Very similar to something like you may have seen when we did the slope formula. Then, if you're also going to look at the bottom length, right, because we need to know what this side length is of our triangle, this whole side length is going to be x2 minus x1. So if I know how far it is from one point to another, I can figure out x2 minus x1. And that is what we can plug into our formula. So instead of having a length for A, I use x2 minus x1 and square it. And instead of finding or having a length for B, I can use y2 minus y1 and square that. And then we have the square root over everything, because at the very end, the last step was to square root to get C by itself. So that's how we use Pythagorean theorem and 2 points to calculate the length of a line segment. So let's look at an example and find the length of the line segment that connects the 2 points A and B below. So I see I have my 2 points, A, negative 3, negative 5, and B, 5 and 4. So I'm going to label my points x1 and y1, and then x2 and y2, just to help me with my formula. Again, you can put it in either one, it doesn't matter. As long as you make sure that, say, if this point is x1, then this has to be y1. It can't be x1 and y2. It's always x1, y1, x2, y2. Again, very similar to the algebraic formula for slope. So I'm looking for the length of AB, or my line segment AB, and I know that that is going to be the square root of x squared minus x1 squared plus y2 minus y1 squared. Again, just taking that from the formula from above. Next step, x2 minus x1. So my x2, negative 3 minus x1, which is 5. That's all squared. And then y2 is negative 5 minus y1, which is 4. And that's all squared. So keep going through, and I'm just simplifying. So negative 3 minus 5 is negative 8 squared, plus negative 9 squared. And in the end, I should end up with, we have 64 plus 81 So we have the square root of 145. And if you want to find an exact value, you can go through and calculate the square root of that, or you can just leave it to get to be a little bit more specific, because if you don't leave, or if you do actually go through and calculate it, you may end up with 12.04 and a few decimal places, so it may just be easier just to leave it as the square root of the number. Example 2, find the distance between P, -3, 7, and Q, 7, -8. So again, same idea, except here we're not given an actual graph to look at, but it's okay because the formula doesn't really rely on the graph. We know, our formula, x2 minus x1 squared plus y2 minus y1 squared. So I just need to figure out my x2 and my 2 points. So the first point P we'll call x1, y1. The second one Q will be x2, y2. And I can just plug those points in. So x2 was 7 minus -3 squared plus, and then y2 -8 minus 7 squared. Then we just start simplifying. Right, so we end up with 10 squared plus -15 squared. When I simplify this, should get the square root of 325. And then at the end, when I square root that, 18.02. And again, that's rounding it. So that's basically the main idea of using the length or finding the length of a line segment. So let's just look at a word problem of where this may come into play. So a plane is flying from Halifax, or from Toronto to Halifax. When the plane is at coordinates 125, 309, the plane develops engine trouble. Ottawa International Airport is at coordinates 97, 215, and Pierre Elliott Trudeau Airport is at coordinates 139, 412. To which airport should the plane divert? So basically we want to know which one has the shortest distance. And whichever one has the shortest distance, that's what we want to travel to. Try not to look at the actual diagram and say, oh, well, going to Ottawa, it looks like it's shorter, right? Just based on what I've drawn. That may not always be the case, right? So don't assume that the image is drawn to scale, right? Make sure you go through, actually calculate, and to show your work. So basically we're going to have to come up with two different lengths of a line segment formula. And we're just going to compare the two answers in the end. So in either case, my first point or at the plane is going to be my x1, y1. And then at each airport, that's going to be my x2, y2. And from there, we're basically just going through and doing our length of a line segment formulas. So if we look at the distance to Ottawa, we know the formula it has to take, because again, the length of a line segment, we're between 2 points, so x2 minus x1 squared plus y2 minus y1 squared. And because we're going to Ottawa then, the length of my x2 will be 97 minus 125 squared, plus, and then my second one, 215 minus 309 squared. Right, so again, just plugging those values in. And when I simplify all that, I should get 96 or 9,620. And then when I square root that, get 98.08. So that is our one distance. So that is going from our plane to Ottawa, we need to figure out the second one, so we need to calculate the distance to Pierre Elliott Trudeau Airport, PET. Again, we're going to be using the same formula, because it's still going to be between two points. We want to find that distance. So x2 minus x1 squared plus y2 minus y1 squared, and all of that is square rooted. And I'm just plugging in again the information from my points. So my x2 for this one will be, if we zoom out a little bit, x2 will be 139 minus 125 squared plus 412 minus 309 squared. And when I simplify all that, I should get 10,805. And when I simplify that, 103.95. So looking at these two, I think it's clear we can tell which one is shorter. Even though it's by a little bit, it's still a shorter distance. So therefore, the plane should divert to Ottawa. And that is basically how you are using 2 points to calculate the length of a line segment. So again, just make sure you identified your 2 points and you have your formula to plug them into to calculate the length.